Let's try to solve another Leetcode problem. 1963. Minimum number of swaps to make the string balanced. So we are giving a zero index string as of even less. So this is really important because it is even less, but basically this means it is always be valid. And we are also having half of the opening brackets and half of the closing brackets. So for example, the string consists of exactly n divided by 2 opening brackets and n divided by 2 closing brackets. This means it must be valid. So a string is called balanced if and only if. So the first condition is it is an empty string, definitely it is okay, or it can be written as AB. So both A and B are balanced strings. So this AB just means it can be written as opening brackets and closing brackets. So this is AB, and it can also written as a C with opening and closing brackets. So C is a balanced string. If C is a balanced string, C gonna equal to something like this. Yeah. So you may swap the brackets at any two indices any number of times. So we're gonna return the minimum number of swaps to make us balanced. So if you are just checking this problem, it seems it's gonna be a really hard problem. Actually, it is not. What you're gonna do is that why not just check some examples, just to try to figure out maybe we can solve this problem by using some very basic mathematics skills. So for the first one, in the middle, this is open and closing brackets. It is okay. We don't need to count it, but there's one closing brackets from the beginning, but there's no open, and then at last there's an open bracket. This means we're gonna have one swap. So one swap is okay. Yeah, so we can make the swap from index 0 with index 3. It's going to be one swap, and we're going to return 1. So for the second case, from the beginning we find 3 closing brackets before we find any opening brackets. So this means definitely we're going to do some swap. Yeah. So how many swaps? It depended on how many closing brackets from the beginning, because there's no opening brackets. If there's an opening brackets, we're gonna eliminate and we're gonna cancel the closing brackets, and we're gonna just delete it. But there's no opening brackets at the moment. We find 3 closing brackets. So if the number is odd, we're gonna use divided by 2 plus 1. So it's gonna be 2 swaps. As we can see, the answer is 2. Yeah. So this is just the idea. So this is 3 closing and 3 open. So what we can do? So for example, we're gonna swap this one with this one. What are gonna happen? Yeah. Or maybe we're gonna swap this one with this one, because this is better, maybe. Yeah, we're gonna swap this one with this one. So here, those two are okay. What left behind is only 1, so there's another swap. So in total, it's gonna be 2. So for this one, we don't need to do any swap. So exactly how can we solve that? So if from the beginning there's an open parenthesis, do we need to consider? No, because after that, according to the definition, it must have a closing parenthesis. So if we find an opening parenthesis from beginning, we don't need to count it. Only if we find the closing bracket from the beginning, we're gonna continue to count it. So for example, this is closing. If we find some open, so we're gonna just yeah, if we find a closing, okay. If we find an open, so for example, we find 3 closing parentheses, so the difference is going to be 3. So we're going to define a difference. Now we find an opening parentheses, so 3 minus 1, it's going to become 2, and then 2 minus 1, it's going to become 1, and we find another open, it's going to become 0. So this means after here, all those strings will be eliminated because we find some closing and some opening brackets. Yeah. Now what are we gonna do? So our idea is that we only consider the closing brackets from the beginning. So if there's no open, this is always closing, and we're gonna use this number, how many of them, divided by 2 plus 1 if it is odd. So if it is even, so it's gonna be this number divided by 2. We don't need 2 plus 1. Yeah. Now let's just use this kind of idea to solve the problem. So we're gonna define a diff and the result. So from the beginning, the diff gonna be 0 and the result gonna be 0. Now we're gonna check the brackets one by one. So if this is from the beginning, if this is a closing brackets, what are we gonna do? So the difference is gonna plus equal to 1 because this is really important. Otherwise, it means it is opening parenthesis, so the diff gonna minus 1. So what we consider is the diff. So the diff must be more than 0. Yeah, if it is less than 0, it is okay because it is just opening parenthesis. We only consider the closing parenthesis from the beginning. Yeah. Now, if it is the difference is more than 0, it means from here, from this character C, there must be more closing parentheses than the opening parentheses, and we can directly check the result. So the result is gonna be, but we need to check, yeah, even or odd. Yeah. So if the difference is odd, what are we gonna do? Yeah. So if the difference is odd, what are we gonna do? So we're gonna update the result. It's gonna be the maximum of the result with difference divided by 2 plus 1. Otherwise, if it is even, we're gonna update the result with difference divided by 2. Yeah. Now we can directly return the final result. As you can see, everything is just a little bit code, but even though you have to think about it, how you're gonna approach this problem, because the closing brackets from the beginning is really important. So from here, if we find some closing, it is okay, but if we find some opening parentheses, the difference is gonna minus 1. Yeah. Even so, for example, let's just use let me just submit it first and check those 3 examples. Now as you can see, it works. Yeah, now as you can see, it passed all testing cases and it's pretty fast because the time complexity is gonna be 10 to the power of 6. Let's just check some examples. Maybe it is helpful for us to understand what happens. So for the first example, this is a closing parenthesis. Okay, so the difference is 1, and then the difference is more than 0, and the difference is odd. So what are we gonna do? So the difference is gonna be 1. So the result is gonna be 1. Yeah. Now we find an opening parenthesis. So what happens if we find an opening parenthesis? Because for the second one, if it is open, so the difference is going to be 0. If it is 0, we don't need to do anything. And next, we find another closing parenthesis, so the difference is going to be 1, right? And here, the maximum result is going to be 1. And then we find an opening parenthesis, so the difference is going to be 0. So the final result is going to be 1. Yeah. And let's just check the second case. So for the second case from the beginning, so the difference is going to plus 1, plus 1, and plus 1. It's going to become 3. So the difference is going to be 3. So here the difference is going to be 3. And then the difference is more than 0, so the difference is odd. So the final result is going to be 2. Yeah. So this is going to be the maximum. So next, if we find the opening parenthesis, so the difference is going to become 2. And here it is even. 2 divided by 2, it is 1, but we've already found the maximum. Yeah. And next, the difference is going to become 1, and the difference is going to become 0, so it doesn't matter, because from here, we've already calculated the maximum. And similarly for the last example. Yeah. I think that's all about it. Sometimes for this problem, actually, it is some greedy ideas, and sometimes it's really difficult to explain why I can think about it, and why I can think of such kind of approach to solve the problem. Actually, it is some greedy idea, because if it is opening parenthesis from the beginning, it is okay. But if we are finding some closing parenthesis, so we're gonna count it and we're gonna check the maximum. I think that's all about it. Thank you for watching. See you next time.